I'm going to be doing problem 15.65, so it reads, on your first trip to planet X, you happen to take along a 200-gram mass, a 40-centimeter long spring, a meter stick, and a stopwatch. You're curious about the freefall acceleration on planet X, where ordinary tasks seem easier than on Earth, but you can't find this information in your visitor's guide. One night you suspend the spring from the ceiling in your room and you hang the mass from it. You find that the mass stretches the spring by 31.2 centimeters. You then pull the mass down 10 centimeters and release it. With the stopwatch, you find that 10 oscillations take 14.5 seconds. Based off this information, what is G? So here's a picture. I've gone ahead and drawn the mass, 200-gram mass being hung 31.2 centimeters from the roof, and you can see in the second image, after stretching it 10 more centimeters, which is a total height of 41.2 centimeters, when you let go, the spring begins to oscillate up and down. So what I wanted to do first is define our omega. So we have 2 pi times our frequency, and per what we're given in the problem, we have 10 oscillations in 14.5 seconds, so that's going to be our frequency, and so this is our expression for omega. In order to eventually solve for the value of G, we're first going to have to determine the value of K. So I've set our omega equal to the square root of K divided by M. So in the problem we were given M equals 200 grams. We're going to want to make sure that we convert the grams to kilograms. So you have the square root of K over 0.2 is equal to 2 pi times 10 divided by 14.5, which this value here is also equal to 4.33 radians. Make sure your calculator is in radians mode since we have 2 pi here. So you're going to want to go ahead and square both sides to get rid of this square root here. You end up with K divided by 0.2 is equal to 4.33 squared, so then you get your K is equal to 3.75. So now that we found our K value, we can set our force equals to mg, but in the case that we're working with a spring, this is also equal to K times X. So we know our mass is 0.2 kilograms times g. We just found the value of K, and we're going to convert that 31.2 centimeters that the spring initially stretched into meters. So we get this. In order to find G, we just have to substitute over here, 0.312, divide by 0.2. And once you use a calculator, you get that the value of G is 5.85 meters per second squared. And that's how you do this problem.